Okay, so let's say you have a problem where you have to solve for x and you know that the triangle is a right triangle. Well, the main tool that you're going to need for solving this type of problem is the Pythagorean theorem, which, as we know, is a squared plus b squared equals c squared. This is such an important formula. I cannot stress it enough. Memorize this. You will use it for the whole year. So the first thing you're going to want to do is understand what a squared plus b squared equals c squared actually means. So let's dissect this a little bit. So a and b have to be the leg lengths, and c has to be the hypotenuse. So we know that the hypotenuse is the longest side of a triangle. So in this case, we're solving for the hypotenuse, which is x. So one mistake that I see a lot is people saying, oh, well, this whole term must be equal to one of the legs. But no, that's not how it works. So for a, it would be 3 or 4. It doesn't matter because since both of these are legs and they're both squared equally, it doesn't matter which one you put in front of the other. So let's say a is 3 and b is 4. This does not mean that a squared is equal to 3. This one is the one that is correct. A is equal to 3. So that means, and the same thing with b and c. So this would imply that 3 squared plus 4 squared equals x squared. So once we solve this out, you get 9 plus 16 equals x squared, and then 25 is equal to x squared. And then to get rid of the square, you're going to have to take the square root of both sides. So the square root of 25 is 5, which ends up being x. So that is your answer to solve for the hypotenuse. But another case you'll see with right triangles is having to solve for one of the legs, and this is where it gets a tiny bit more complicated. So let's say that this side is, 6, and this side is 2. So, and this side, let's say it's y. So again, we're going to have to use a Pythagorean theorem, a squared plus b squared equals c squared. But this time we're not solving for c because we're not solving for the hypotenuse. So first, let's figure out what we have. So we have a leg, so let's say a, let's make it more clear. Let's say that a is 2. We know what the hypotenuse is, so c is 6. And b, which is the one left over, is y. Because we don't know what b is, because we don't know what y is. So if we plug these into our equation, 2 squared plus y squared equals 6 squared. We can solve all the exponents first. So 4 plus y squared equals 36. And then you'd subtract 4 from both sides. You get y squared is equal to 34. You have to take the square root of both sides to get rid of the square. So then you get y is equal to the square root of 34. So the biggest takeaway from doing this is that you really, really, really have to be careful of what you're plugging in where. So if you're solving for the hypotenuse, you do not want to have your variable as a or b. It has to be c because that is what the hypotenuse is. Similarly, if you're solving for one of the legs, your variable should not be c. You should not be solving for c because you're solving for one of the legs. So one of the legs, a or b, has to be the variable. And I cannot stress this enough. This is such an important concept because it applies to the rest of integrated 2 and beyond that, the other math classes you're probably going to be taking throughout your other years of high school. So bottom line is you want to be solving for, or when you're plugging things in, you need to plug it in as just a. You cannot plug it in as a squared. Same with b and c. And you have to be careful of what you're putting where. And that is how you solve for the sides of right triangles.